All right, next up is Craig, my partner. He's going to be talking about sustainability's economic win. He took the trace and sand. I think the wonder of both having Portia and Craig is that they could work and do their studies on their work. And that's exactly what he's done. So you can hear what he says and the whole principle of the fallacy that the better you follow sustainability, you're going to lose money. And in soils applicable agriculture, that's just not the case. All right. So I'm going to hand over to Craig now, and yeah, there's his title. Okay, Craig, over to you.
Thanks, Philip. Thanks everyone for the opportunity to be able to share with you guys some of the stuff that we've been learning. I think that Graham's given us a lot to think about and a lot of stuff to work on. I think a lot of what he's saying is what we've been trying to say for a long time. So hopefully he's motivated you guys a step further in that direction. As Philip mentioned, I'm going to look at it from maybe a slightly broader perspective than the specific soil that everyone else has been mainly focusing on. Just by way of introduction and starting off, when we talk about sustainability, there's three pillars that we are speaking about. And it's the economic, environmental, and social. I think it's really important that we don't leave any one of them out, because we can get quite fixated sometimes. It's like economic sustainability, that one resonates with me, I'm going to go for that one because I agree, I need to make more profit. But it isn't sustainability if we aren't also addressing the economic and environmental and social aspects of it. And in a similar way to what Graham was referring to, the stool for soil health, if you remove any one of those, it's also out of balance and it's no longer sustainable anymore. And I would encourage you guys that when you approach the way that you manage your farms, that you think about it from all three of those perspectives. And that's what I'm going to be chatting about today. That you're not going to sacrifice the economics in order to address the other two. Just some of the principles, I'm going to quickly run through these. We've already addressed most of this. We're looking at agriculture, farming systems from a holistic perspective. We're not just focusing on one thing and then heading off on in that direction. As Philip already shared earlier, it's an integrated, interrelated system. As you improve the soil, you improve the opportunity to use water more efficiently. And as you use water more efficiently, you use less electricity, so you reduce your carbon emissions. All these things are interrelated with each other. You mess up your soil more, you have to use more fertilizer, results in higher carbon emissions, worse nutrient utilization. They're all interrelated with each other. So the basic principles are that we're trying to minimize the inputs while we optimize the outputs. Note, I don't say maximize the outputs, because maximizing is a different thing to optimizing. Maximizing same is going for the most without any idea of how much it takes to get there. Optimizing is an efficiency factor. We do it efficiently, which again relates back to profitability. We want to work with nature. Philip made reference to it earlier. There's a lot we don't understand about nature, but as we learn more and more about the way that natural systems function, we can unlock those in our farm systems and reap the benefits of it without having to always pay for expensive things to make things work. And then obviously there's a lot of technology that's available. Some of it is in the form of information, some of it is in the form of better equipment, some of it is in the form of better ways of measuring things, and there's a lot out there that we need to make use of in order to get these systems to be more sustainable. Okay, so I'm going to be looking at a few dynamics. I'm going to start off from a soil health perspective. Graham addressed this quite comprehensively, but it's of utmost importance that we understand how carbon works on farms. We've heard now, carbon in the soil is imperative to a healthy soil. And there's a lot of dynamics that are influencing the movement of carbon into the soil and out of the soil. So soil organisms respire, they give off carbon dioxide. That's part of the natural process. There's enteric fermentation and the emissions from manure, animal respiration, plant respiration, the fossil fuels that we use on farms. Those all result in emissions from the farm. And those are an environmental impact. That's when everyone's talking about climate change, everyone's talking about increasing atmospheric carbon levels that are leading to a more uncertain climate. These are the influencing factors. And because there are so many on dairy farms get nailed for this. And dairy farms don't have a very good reputation. Dairy, any form of animal agriculture, especially ruminants, get hammered because we emit all of these emissions. But what we mustn't forget, which is what Graham referred to, is that we've got these green pathways that we can pull the carbon back into the soil and store it. And if the net movement of the carbon is positive into the soil, we actually can create a positive impact. And I think Graham has already explained very well how photosynthesis is the key role player in that process. So what I did a while back, and Philip made reference to this earlier, is that I looked at the greenhouse gas emissions, which are the blue bar. That's how much per litre of milk that is produced, how many greenhouse gas emissions there are on the farm. You can see it varies. It's somewhere around 1,800. And then the green bar looked at how much carbon we stored in the soil. So when we take our first soil samples, that's our baseline year. Now we know, where did you start? How much carbon did you start with when we started measuring it? Obviously you've come from further back than that. And then we can look at over time how much that carbon increases. So on this farm, they increased their carbon converted back to per litre of milk. They increased their soil carbon levels by more than what they emitted carbon over that period. I think it was a 3-year period. That farm, so I don't want to confuse you with terminology. Graham used the terminology carbon positive and neutral and negative. He was referring to in the soil. I'm talking about as a whole, as a balance. All of the farms here with green that's above the bar, those are all carbon positive according to Graham's definition. According to my definition in terms of the bigger picture, that farm is carbon positive even taking into account the emissions. That's crazy. That we can start telling unbelievable stories out there about how dairy farmers are not the enemy, but can potentially be the solution. The problem is when we start having farms here, where we're losing carbon from the soil and we're emitting carbon. Those are the farms that people are hammering, because those are not regenerating the soil and they're causing emissions. And how do we move ourselves to be there? And I'm coming at it from quite an environmental perspective, but I'm going to share with you just now how that is also an economic win. And you've already heard why it's such an important factor from a soil health perspective to increase your carbons. Another dynamic of soil carbon is the storage of water. Philip made reference to it earlier of how you can actually build a dam under your soil by just increasing your carbon levels. So this is data that we've collected, and we found that for every 1% increase in carbon through 60 centimeter profile, you'll store 230,000 litres more per hectare. That's ridiculous. How's that for drought resilience? And if this is where we want to get to. So that's just emphasizing, and when we think about it from an economic perspective, I don't have to make the argument for how storing more water in the soil is an economic win. You guys well understand that. Moving on to the dynamic around nitrogen in the soil, it's been hammered on and hammered on and hammered on. This is that total nitrogen measure that Philip made reference to earlier. It's just an example from a farm with, on average, not that bad in terms of too high soil nitrogen, but that's 7 tons on their irrigated pastures, that's 3.6 tons on their drylands. In the top 15 centimeters, that's not even taking into account all the lower depths and how much more nitrogen there is there. And as has been referenced repeatedly, how do we make use of this actually, rather than just say, oh well, it's total nitrogen, so it's not available to the plant, so let's just add more available nitrogen to the farm system and make it less profitable. How do we unlock that? And Portia is going to go into much more detail with regards to these results and the correlations that we've been finding between mold. So mold is the type of fungi That's the filamentous fungi. Mycorrhiza is an example that Graham made reference to. Saprophytic fungi, which you would associate with like what grows on bread. Bread mold is a saprophytic fungi. And those break down organic material and provide nutrients. So what we found is that the mold correlates positively with carbon, and as does yeast. Yeast are single-celled fungi, so they act in a similar manner to bacteria, so we can use them as an indicator of what the bacteria profile in the soil is looking like. As we've heard, more carbon is more food, so we'd expect more life. The active carbon is the portion of carbon that's more readily available for the plants to use, the more sugary substances, and that we found to correlate positively with mold. What's the most fascinating though, and I think Portia will explain it in more detail, but we found a negative correlation between total nitrogen and mold. That means that the mold doesn't like too much nitrogen in the soil. And where we used to just think about all that total nitrogen as opportunity, the more we have, the more opportunity we have. Actually, the more we have, the more we have to work on getting the mold back into the soil. So the last thing we want is to just continuously add nitrogen to the system if we want to rely on healthy soil to do the work for us. I'll let Portia explain in more detail what all of that is about. Making reference to something Philip also mentioned is if we only know what's happening if we've measured it and if we have an idea. So one of the ways is to go and visually assess the health of your soil as you go out and see it and respond in management. And the other way, and that's where the power of the database comes in, is to test that soil year to year to year. And you can start developing a story, to start developing a picture of what is happening over time in your soils. And we can start asking the right questions. But as we go about the soil testing, it doesn't help if we take that information and then say, what's the average for the farm? Let's just treat it the same. On average, I don't have enough potassium, let's put potassium everywhere. We understand that inherently with fertility, but do we understand that with biology? Because if we've got healthy biology, if we've got that life that's green, then we can start saying that soil's got all the dynamics that we needed to have to start doing the processes that Graham was talking to us about. So why don't we start applying those principles on those pastures? Because those are the ones that are perfectly ready to respond to that, to pull back on the fertilizer, because we know we've got the organisms to do the job. And then on these ones that are red, we can say, okay, we're still far off. How do we get them to be green so that they're also working for us? But if we just blanket treat the whole thing, we're not going anywhere really. And we're going to carry on being reliant on our historical and habitual management practices. Because a lot of the time it's habit. Why do you put down fertilizer? Because that's how it works. Why do you graze like that? Because that's how it works. And we've really got to start challenging ourselves to treat areas differently as we learn more about specific portions of our farm. Okay, moving on to the whole dynamic around environmental impact and productivity. So, I'm deeply passionate about seeing agriculture reduce the impact that it has on the environment. And I don't think, and I've never thought, that you need to sacrifice your productivity to do that. And so, Philip taught me that 7 years ago when I started working here, but everyone wants evidence, so I took that as a topic for my PhD to say, well, let's find out. So what we looked at, and don't worry about all of the detail of this is just to say that it is legitimate research that's been published internationally, if you think I'm just making it up. But we looked at nitrogen use efficiency as one of the environmental impact indicators. The less efficiently you use nitrogen on your farm, the more there is that can be a pollutant. And that's a significant environmental impact. Greenhouse gas emissions, I've already made reference to that. The more greenhouse gases we emit, the higher environmental impact we have on our farm systems. So I took those two environmental impact indicators and I compared it to farm productivity, profitability, to see is there a relationship between the two. And what we found is that there's a positive relationship. The better you utilize nitrogen, the more profitable your farm is. It's so obvious, it doesn't even seem like it's necessary to do the research, but it is. And the less greenhouse gases you emit, the more profitable you are. So it's a win-win. We can have reduced environmental impact while being more profitable. And the dynamics that influence this, so I took all the farms and I grouped them into the highest profitability group, the middle profitability group, and the least profitable group. And then I looked at some of the indicators that I would hope everyone is familiar with regards to economic productivity. So milk production per hectare was the highest on the highest efficiency group, and the stocking rates obviously were the highest. Those two are associated. That's a dangerous graph on its own, because it could just say increase your milk production per hectare. The important dynamic is that those farms didn't increase their milk production per hectare by feeding more. They increased it by utilizing their pastures better. So they fed more efficiently. So they used less concentrates per litre of milk on the more efficient farms to produce more milk per hectare. The least efficient farms didn't utilize their concentrates well. The roughage is not as strong of a relationship. We've seen through the drought, roughage is very closely correlated to rainfall. The more on relatively efficient farms, the less it rains, the more food you need to buy in. Obviously, if you're completely wasting your pasture and you're buying in roughage to replace it, then you've got more significant problems. But if you're utilizing your pasture well, you're going to have to buy roughage to ride through the drought. So it's not as big of an influence, but the concentrates is a big influence. Are you using concentrates to make milk, or using grass to make milk and concentrates to supplement that so that you maintain it? Because that's a big question. There's a lot of farms, obviously through the drought, we're feeding less than 50% of our energy is coming from grass. The other 50%, more than 50% is coming from food we buy in. But we call ourselves past examples. So I looked at, this is just application of N, kilograms of N per hectare. 2008, 14, 17, 18 on 3 different farms. We don't have the data for the orange farm historically, but here these guys were at over 400 kgs of N per hectare. And we've brought it all the way down in 2018 to below 200 on average across the farms. And the problem then comes in, what's going to happen to my growth? The growth's increased. And your fertilizer versus growth, which is the efficiency indicator of it, significantly improved. Because this one tells you how much money are you spending in order to grow your pasture. The higher that bar is, the more money you are spending to grow that pasture. And they've brought that down all the way to around 10. And I'm sure we can, and especially applying these things that Graham is talking about, we can bring that well below 5, and the end goal is 0. And it must be achievable somehow. How are we going to get there? There's so much nitrogen all around us. And that's just from nitrogen. The other fertilizers come into play as well. The dryland pastures, we don't have as much information on them, but I just included it there because the dynamic is similar. We were using way less N on the dryland pastures. This specific farm with the blue has completely reduced the amount of N that they're using on their drylands. And yes, the growth was not great in 2018, but I don't have to explain to you guys why that was the case. But it's scary that people were using tons of fertilizer through the drought and growing no grass. Because what was the point of that? And how are we thinking about this? How are we measuring it? And do we understand what kind of influence it has? Because as we don't utilize N well, we cause a hell of a lot of environmental problems. This is just a graph showing the improvement in fertilizer efficiency that happened. So especially on this farm with the red. And that, that's on average through all the farms. That's the amount of N fertilizer that was applied reduced significantly. The amount of fert versus growth improved significantly. And the amount of actual just growth in tons improved over that time, even though the fertilizer was reduced. And the efficiency on the drylands, the same story. So the evidence is there. It's not like we're just saying the principles are there. The evidence is there. This is doable. But we need to push it further than this, because we're still applying our 200 N per hectare, and we need to challenge it beyond that, I believe. This is just a picture of what happened to the soil carbon levels. So on this is the dry lands and the irrigation. That's the one farm. That's overall what's happened on the farm. This farm, you can see there's been a slight drop in the soil carbon levels. The drought has influenced that. We grow tons to make carbon. We didn't grow tons through the drought. So our carbon levels reduced. So that's not in your control. But what is in your control is going forward. This farm has significantly increased its soil carbon levels. And that's what's led them to be able to use less fertilizer, be more efficient in. This is an example of what's happened with the mineral balance. So Philip explained the mineral balance. We look at all the nutrients that come onto the farm. Fertilizer, concentrates, roughage, animals, and then removal is milk and animals. So the things that you bring on cost you money, the things you take off give you income. The more efficiently you manage that dynamic, the more money you make. But also then we can start reducing this excessive amount of nutrient. So that's nitrogen, that's phosphorus, that's potassium. Okay, N and P have much worse of environmental impact than what the K has, but they all have an environmental impact. And we need to reduce the amount that we are generating that goes back into the environment, causing significant negative environmental impacts. Water, you're messing up your own water quality a lot of the time because you've fertilized there and then it runs into your own dam. And then we're asking the question of why don't we get the response when we irrigate? The same kind of response we get when we get rainfall. Because rain is brilliant, perfect quality water. And our own water is terrible quality water. The dams in South Africa have got really, really terrible quality water. And it's not only agriculture, but it is agriculture that's contributing to that poor water quality because we're shoving nutrients into the water systems. And it's actually becoming quite a large challenge. And I understand a lot of the time it is downstream from you, but I encourage farmers to have that sense of environmental responsibility and stewardship. I understand I wouldn't be able to make that argument without saying, well, you'll make more money. So I'm saying let's have the environmental responsibility, but we can make more money at the same time. It's the same principles. This is just showing the efficiency improvement over time on that farm. So N utilization has especially improved. And I'm having lots of conversations. You can see I've been working with this farmer since 2013. We have lots of conversations. We had one at tea time about how to get better at this and the fact that we need to get better at this. If we look at the opportunity cost of all that N, P, and K, so saying that what if we hadn't needed to bring it into the system? And we could save ourselves up to 8,000 Rand a hectare. It's a lot of money that we're throwing into our, and to a large extent, all this excessive N. So this, the red part, is building up in our soils, and as I referenced to earlier, it's causing a negative impact on our soil life. Looking at it from a greenhouse gas emissions perspective, so this farm has done a really great job of reducing the amount of greenhouse gas emissions over the years. And one of the things that's had quite a big influence is that they changed the way they manage their effluent. Because if you let effluent sit in a slurry dam that's anaerobic, that just generates emissions like crazy. And Graham made reference to it earlier that you're also losing the valuable nutrients. So if we don't manage our effluent systems better to fully utilize those nutrients and to minimize the emissions, we're losing out on opportunity. So, do you know whether your effluent management system is ideal and are you making full use of that effluent? The milk productivity per area, as I referenced earlier, as you increase your production per hectare, you increase in profitability and you reduce your environmental impact. That's what's happened on this farm. The cow efficiency, liters per 100 kg live weight, this guy is doing ridiculously well to convert food into milk. And that's also a large component of efficiency, which relates back to profit and relates back to reduced environmental impact. Concentrates, the amount of concentrates that are used also have been significantly reduced from 400 down to just above 260. So, I know there's guys in Cookhouse that are doing much better than that. The roughage, as I referenced earlier, that's reliant on rainfall. We see we use a lot more roughage when we had less rain, so we can't read too much into that at the moment. The fertilizer efficiency, so again, the amount of N per hectare, we were pushing 500 at one stage. And one of the things that must be taken into account, a lot of that N was chicken litter and compost. It's not necessarily all urea, but I'm saying it's still N that's coming in. It's not as harmful as what urea is, but it's still N coming into a system that's not being efficiently utilized. This farm used it to build up the soil health, which he's now using as an opportunity to get to the point of better efficiency. So we understood what we were doing at the time, but the challenge to them now is that they must make use of it. They've built, now what? Now you've got to make use of it. And that's what they've started doing. But there's still a long way to go. And that kgn per ton of pasture that efficiency has significantly improved. But again, we've still got a long way to go. This is still above 15. We want to get it down below 10, below 5. So the main things that influence this dynamic, and the main factors that are found to influence that, if you want to reduce your environmental impact and improve your profitability, grazing management is a huge thing. You've got to utilize properly. You've got to make sure you're not overgrazing and reducing the opportunity to store carbon in the soil. You've got to make sure that you're grazing late enough that you've allowed the grass to do the full work of pumping carbon into the soil. Philip always talks about the carbon pump. Are you using your grass to pump carbon into the soil? And that's all revolves around how you manage your grazing. We've got to rethink fertilizer. I don't need to dwell on that. That's now obvious today. We've got to make use of multi-species and especially start using the legumes in order to unlock that nitrogen. That's an opportunity. Minimum soil disturbance. I hope, and I think that's not as big of a deal anymore. I think we understand that well now. We're not coming in every third year and tilling our soils up and re-establishing them, because that's just destroying all the structure, getting rid of all the carbon. Cover crops are a really good opportunity to jump your soil forward, because you can push a lot of roots into that soil over a season if you can grow a good cover crop. Effluent management, I've referenced that now already. You've got to figure out how to make use of your effluent effectively, both from a nutrient perspective and to reduce emissions. A big problem with effluent management is that we've identified how to do it well, but then we've just got 2 pivots, and we've put all the effluent on those 2 pivots. Now that's a problem, because magnesiums are too high, sodiums are too high on those soils, nitrogen levels are crazy high, and then the rest of the farm is too low in potassium. We should be redirecting that effluent there. I understand it's a cost, I get it. I'm not just throwing things out there saying do this, do this, do this, do this. I'm challenging you to think about how we can start doing these things. Because we can start with the next pivot and then the next pivot, and as we grow and develop, we'll get a more sustainable farm system that we have. Irrigation scheduling, we haven't dwelt too much on water today, but irrigation scheduling is a huge deal. Inefficient irrigation uses more electricity than what you need. That's a greenhouse gas emission. Inefficient irrigation messes up the soil, either by keeping it too wet all the time or not having enough moisture. Irrigating too often with too little keeps your roots up near the top, because that's just where the water sits. Too much irrigation, anaerobic conditions, all of these are negatively influencing the soil, negatively influencing growth, negatively influencing the overall efficiency of the farm. And that irrigation scheduling is something that I don't think that we're that good at, that we can learn a lot about irrigation scheduling. So that's my what I've learned, I think I can say, over the last couple of years. Always hoping to learn more and grow more, and I think that's one of the really amazing things about having Graham here, because we're learning too. And he's challenged us to look at things like active microorganisms, and we will look at that. And that's what Philip made reference to, that this research is only possible through the database that we have and that we continue building. And our commitment is that we will continue learning, and as we get more farms into the database, we can learn more, and we can support you guys better in learning how to manage more sustainable farms. Thanks.